In today's session, we are going to discuss about the laser. The objectives of this session are: we'll understand the history of the laser, how the laser was invented, characteristics of the laser, how the laser is different from the ordinary light sources, basic principle of the laser, levels of the laser, anti-arc laser, and applications of the laser. Basically, laser is an acronym from light amplification by stimulated emission of radiation. So we'll understand the each and every word of this. What you understand by light, what you understand by the amplification, what you understand by the stimulated emission, and what you understand by the radiation. According to the de Broglie, the light has a dual nature. One is a wave nature and the second one is a particle nature. According to the wave nature, your light is an electromagnetic wave which consists of electric field vector and magnetic field vector, which are vibrating perpendicular to each other and also perpendicular to the direction of the propagation of light. According to the particle theory, the light is a bundle of definite energy which are known as the photons, and the energy of the individual photon is given by E is equal to h nu, where E is the energy, h is a Planck constant, and nu is the frequency. Whereas Planck constant has the value 6.625 into 10 to minus 34 joule into second, and nu is the frequency. The concept of stimulated emission was very old phenomena as such. The basic or the foundation was laid by Albert Einstein in 1917. He observed the very simple process. When you give the energy to a particular atom, the energy is absorbed and your electron make the transition from lower energy to the higher energy, and that particular process is known as the absorption. So in the many of the cases it happens like this only. Okay, whenever you give the energy, your electron will go from the ground state to the upper level. But Einstein suggested that there is another possibility also. When you give the energy or the external photons, that photon will stimulate the already excited electron from the higher state to the lower state, and as a result you will get the radiation in the output, and that emission of radiation is known as the stimulated emission. Let us see once again. When you give the external photon, right, this photon, there is another possibility that this photon will stimulate the already excited electron to come down, and as a result you will get the radiation, and that radiation is known as the stimulated emission because it is a forced emission. Stimulated emission is the forced one. It requires the external force to execute. So it took around 34 years to demonstrate this particular principle, and in 1953 these three gentlemen demonstrated the stimulated emission using the microwave, and that is known as the microwave amplification by stimulated emission of radiation, and that is popularly known as the maser. And after 7 years they shifted from the microwave frequency to the optical frequency, which is popularly known as the laser, that is the light amplification by stimulated emission of radiation. So that's how your laser was invented. It took around 40 years to convert the basic theory into the practical. There are 4 basic characteristics which makes your laser unique from the ordinary sources. First one is a highly monochromatic. Laser is a highly monochromatic light. That is, mono means single and chromatic means color. So laser is emit the single wavelength. Highly coherent. All the photons are emitted in the same phase. They are in the same direction, and as they are directional, so the area of the laser light is very less, so the intensity is very high. So These are the basic characteristics of the laser. We'll continue this in our next session. Thank you.